going to talk about a concept called hoisting state. Okay? So now we kind of have the basis of React, and we have this state. And you definitely want to have state, because in a user application, it's facing users, they're going to be doing something interactive with the page. There's going to be some sort of state that exists. And in React, we do something called hoisting state. And so you'll have seen that we had that one component that had all of its state held to itself. But what I'm going to show you is that we want to actually move that state up. And it depends on the use case, but most of the time we want to move it up. And the larger your application becomes, the more often you do this. And so let's look at hoisting state. So we want to share the state that this component here has. Let me just break down this example. So we have 3 components. So you probably saw earlier we had like a component demo, and component demo called 2 other components inside of it. Those are children components. These lines represent children components. So you can think of this as the component demo component. You can think of this as the header component, and you can think of this as the content component. Well, let's say we changed out the header with the timer component here, okay? And so it's stateful. So this red square, I hold state. I own this state. Every time that the timer updates, I'm the only one who knows. Everyone under me could know because I could pass it as a property, but I'm the only one that knows. No one above me knows. And because no one above me knows, blue doesn't know, but it wants to know what time it is. And so we have this problem of how do I get the state over to the blue one? So there's many ways to do it, which are fun because of life cycles. But the typical way that we do this is we utilize that common ancestor. So we had that component demo or that top-level component. And what we've done is we've taken the state from here, and we've turned it into a stateless component that takes the property time. And we've passed our timer up to this top-level component. And now we can also pass time down to our left component. So now everyone below the stateful component can receive that time. So we've reorganized where our state is. We've hoisted it up. And this is something that we do in React a lot. Just go over, this is kind of the basis of container view architecture. And what we've done is we've built some container component to manage the state in our tree. And we've built presentation components underneath it to pass that information down. And even methods that we may need to call. So say you have some sort of input, and the user types something in, and then they hit enter. That's a method, right? I've hit enter, I've submitted something. Even that function can actually be held by the container, because it has all the state. And because it has all the state, I need to pass a function down to you that tells me when the state needs to change. So I give my children functions as well. And this provides a clean separation of concerns. So our presentation is just the presentation. Our stateful container is just the container. And this is like a simple application overview of what is emerging in React today. Oh, yeah, and finally, data only has one direction. It's just one direction of flow in this case. And again, we know it's one direction of flow because the methods are created up here and passed down here, but all the state lives up here. And in order for this to update the state, it needs to call some function that tells this to update. And when this updates, it passes it down. So we have a cycle. Okay, so now that we've gotten through hoisting a state, let's talk about the complications of just basic container view. So for small applications, it works very well. But there are some questions that start coming up, such as if I want to remove or add other container components, where should I put that state? So now I have multiple container components. Where does that state go? Is it just in each individual state? What if I need to share that state between 2 container components? Should I make 3 container components, or should there only be one container component, and the other two that had their own state, substate, we just push that right back up to that container, and now I've got more presentations, and I only have one container. So I'm back to one anyway. It's finding the source of state can also get hairy when you don't repeatedly refactor these components into one stateful God component. You always have this issue of, oh, I have state, and it got passed down to me, but where does it exist? So I can follow it all the way back up to the top, but is it the top? I know that I've hit a stateful component, but it also has props. Is the thing that I have a prop from this? So you keep having to go up this chain. I mean, going up one chain is not the worst thing, but it can get a little hairy and difficult to find where all this stuff exists. And that's why there's a need for a state library. And again, React is a view. It doesn't have a model or a controller. It's just a library, so a view library. So here comes Redux. And so with Redux, we have the most popular state container library for React. And it's based on what's called the Flux architecture. And that's by Facebook again. So we have Facebook. Woo! Love Facebook. And it solves this persistent and shared state for components as a problem because we have, we'll get into more of the details, but it's a very clean way to deal with the state problem that we've had where we keep pushing things up. And Flux, the pattern of Flux is this ultimate state hoisting mechanism that also has this one-way data flow. And so let's look at what that data flow actually looks like. So we saw a model view controller earlier, and this is the Flux pattern. And so you'll notice that the arrows all move in one direction. So we start here at the action. Let's dismiss this action for just a second. I'll get into that. Let's start here with the store. Okay? So here's our store. It exists. It has all of our data. It is something that has everything in it, all the state in our application. Then we have our view. And all of the things in the view come from the store. They don't come from anywhere else. They come from the store. And when a user does something, they fire an action. And that action goes to a dispatcher, which tells the store how to update. When the store updates, the view updates. And then it stops. And that's it. We do an initial store view, and we've stopped. And when a user does something, we do an action, and we stop. And that's it. It's a one-way cycle back to the view where we finish a render. Now, this action over here is only here because users aren't the only things that can create an action. That timer is, for example, not a user-created action. It's a system-created action. So we can have other sources of actions, but once they enter the Flux pattern, they stay within the Flux pattern. They enter, they go to the view, we've stopped until another action occurs. So that's our one-way data flow. So let's talk about Redux and how we implement that. Okay? So in Redux, we have the store as a single immutable state tree. So remember that object that we had before? It can be a very large object. It can have many sub-objects. It can have many keys. It's a very big state tree in large applications. All the state lives there, and it's immutable. And we'll talk about why that property is important. But all state in the app is held within the store, and the store, like in the Flux pattern, accepts messages that describe how the state should transition. So we give the store a message and say, hey, here's this new data, reconcile. Store then does one single update, and when it finishes performing that transition, it emits an update. That's it. That's all Redux does, is it receives a message, updates the state tree, it holds on to the state tree, and it emits an update. So we have, that's kind of the flow of Redux. And then you can also think of Redux as a finite state machine. So I don't know if you're all familiar with finite state machines. I'm sure you're all familiar with finite state machines, but we'll probably have a link in the video just to brush up on that if you need it. And it's in my opinion that God state is better than God components, and I claim databases as my source. There's always one. I mean, you can have multiple, but let's describe how container components are going to work now. So we now have this God component that has all the state and emits changes whenever an update occurs. And so what we're going to do is organize around those events now. So in our container components, we're going to subscribe to the Redux store. And we're only going to listen to subsets of that state. So we're going to select out paths in the state. So, I have a tree of objects, and so I'll listen for A, B, C, and D, and when D changes, I'll update. And the way that we do this update is that I think these are a little out of order, but the way that we do this update is when React or when Redux admits changes, it's going to hand us that state again. And we're going to take that state in our container components, and we're just going to map that into something that's now renderable, and we're going to pass it off to our presentation components. So we're going to take that data from the store, the container component's collecting, and the container component's just going to hand that off to the presentation component. The presentation component's going to render a view that's just solely based on the data that it gets. So it's just we receive some properties and we update. There's no state involved anymore. The state's all handled by Redux. The state just gets injected through these container components. And how we had discussed immutability earlier, and this is where the immutability is going to come into play. Okay, so we've talked about it a few times. And immutability is going to save us in React land because Redux is just admitting that something changed, correct? And we are listening for that change. And we are going to select some data out of that change. But because our Redux state is an immutable data structure, as an immutable data structure, we only change these references whenever something updates. So if I have an object and something changes within me, I update my reference. And that referential change is something that we can use to short-circuit React. And how we do that is React, we hand you this data, and we had handed you data before. So you are a component that exists on the page, your presentation component. And you've received data, and you've rendered once before, and now here's some more data. I want you to go and render that and give me a description of what you look like. But I have handed you the exact same thing. And the reason it's the exact same thing is because it is referentially the same thing. It has the same object identifier that it had before. And when I hand you that referentially same thing, React can short circuit and decide not to render anything because it's the exact same thing. I wasn't handed anything different, and we can short circuit that check to a constant. It's a constant time check. I received object and I checked to see if it was the same reference. It is. I'm not going to render anything. I'm the same. I haven't changed. But if I do change, I'm going to have to re-render everything because I've received some different data, so I'll have to dive into my render tree. But this is where that immutability comes into play. Immutability helps us build these efficient change notifications from Redux because we can respond in React by just short-circuiting entire render trees. So here's that quick update that we get. All right, so now that we've kind of designed this system where we just have the Redux store, and I've left out the external actions just for the simple business of displaying this to you. So we have the Redux store, we have the container, the presentation, the action, very similar to Flux. It's a very pure rendition of Flux. So we have this Redux store, which has an initial state, and the container will read from the Redux store, and then it will pass this data down to the presentation layer. And when a user performs an action, we'll do an action. That action will pass some message to the Redux store. Redux store changes. The container notices a change happens, passes the data down. Okay? And that's the unidirectional flow of data. Now, let's talk about how this scales. This whole pattern that we've been working up to now, let's look at the scalability that we get from this whole design of having this God component and then having many containers that listen to it. So when we scale, we're scaling with respect to domains. So our Redux store can be broken apart into different domains. And these containers can listen to specific parts of the domain or the specific parts of the Redux store. So we can have a container that manages to pull information from the Redux store and only passes its stuff to its render tree, its view. And this container reads from the store and only passes its stuff to its view. Now say we have two sets of actions as well. So we have actions corresponding to this domain and actions corresponding to this domain. But you'll notice that even though we've scaled out a bit, all we've done is we've grown here and we've grown here. But we've grown we haven't really changed the number of connections to Redux store because it's just really, we're just reading once from this, right? It's just one thing. And these guys still only have one kind of view. And this may be a tree, but there's a top-level definite end. And the same goes for this container. And the action, so what we end up doing is we scale with respect to domains. And it's a very clean way to have your system architected. And now let's get on to MVC just as a final comparison. So you remember we had talked about kind of the way that we had this view and we had this model and the controller and how the view talks to the model and the model talks to the view and same with the controller and the view. And let's scale it once. Let's add one more view, one more model, and one more controller. So we've actually scaled significantly the number of connections that we have going on in our architecture. And that's because we don't have one source of truth. We have multiple models. We have multiple controllers for multiple views because this model needed a controller to tell this model how to update. This controller needed to tell this model how to update. But this view actually needed to listen to these two models, and this view needs to listen to the other two models as well. And well, now since this is getting data from both models, we also need to talk to both controllers. And oh my God, my head already hurts. Architecture. It actually matters a lot more than you think. And by planning for it early and using some of the other technologies out there like React and Redux, we can actually design for a really powerful, scalable architecture that isn't available in other MVC or in other frameworks, which are say MVC or whatever the flavor of the day may be. And so that's kind of what I wanted to impart on you guys today. So thank you guys for listening to me. And again, I'm Tyler Wanek with Axosoft on the GitKraken team.